Sound check. Check. Yeah, that sounds good. We'll start it at 6:35. Nobody here anyway, so it'll be okay to wait. For those catching the playback, appreciate you. For those that are going to catch it live here in a little bit, appreciate you. Really do appreciate those that show up. I want to send a shout out to Aquateki for the CashApp, the last stream. Really do appreciate that, man. And your dollars going to work a little bit today because I've been spending like crazy. Spending like crazy, man. Yesterday was my birthday, so this past week I went ahead and bought a lot of stuff just for this prototype, this project, and yeah, real kind of went ham. Sold some crypto and stuff like that. Took some profits on some stuff so that I could fund this project. And of course, from viewers, from viewers like you. Oh, okay. Oof. So, we got a little bit. I want to go back in the last stream real quick because somebody gave me the name for the prototype or for this project. Codename Gamer. It's like Grizzly Automated something, and it's been bothering me that I didn't have the name. So I want to go ahead and try and do that now. Might be hard on the stream. Might make the stream suck for all of 2 seconds here. The more that said it. I thought it was Akuteki, but I thought it was actually a good name. That was clever. Yeah, it was Akuteki. Grizzly Automated Mowing Robot. That's what it was. Okay, I wanna copy and paste that because I'll probably make that the name of the repository or something, or that'll be somewhere in the repository. But yeah, we got a minute here, so let me go ahead and put that in a note here. TSA. Y'all had a good weekend. I got some studying. I'm a cook, and I got some studying I got to do for my new day job. I won't say it's been kicking my ass, but I've been kicking myself a little bit because I'm just going around trying to find, all the documentation. Stuff is all over the place, and so I'm just trying to put it all together. So that so that I can actually move forward and be productive in the group. So that's like a pain, or learning, what's it called? Growing pain, learning pain, whatever, of getting into a new company and everything. Seems like my old company might call me back for some contract work, so I'll be doing that too, and that'd be good. Semi for my birthday, I ordered a new truck, so that'll come in like 2-3 months or something like that if no problems happen. But I ordered the Silverado 2500 that I've been talking about, or I've been talking about it, but ordered a Silverado 2500. Excuse me. High Country. So it's the base High Country package with all the technology packages and all this other stuff and custom wheels. So that'll be cool, but it's like an $80,000 truck. Need something like that for around here for hauling. I actually want/need, mostly want, because I don't need anything that big, but I don't want a 1500. I do want the 2500 because I want to do some bigger stuff later on. What's it called, with land clearing and stuff like that. So that's what's been happening. Yesterday, I don't know about you guys, but for my birthday, I tried to reflect, have quiet time. I turned off my phone, put on Do Not Disturb. Sorry. Excuse me. I put it on Do Not Disturb. I didn't accept any calls. I did talk to my cousin, but because he wanted to talk about land and investing, so I kind of jumped at that because I wanted to talk to. I just like to talk about that and help people out wherever I can. But yeah, so that was a good day, and it was good. I looked around my house. It's been a year since I've been here, and it's always nice to have those days of reflection. The way I put it in terms of a birthday is everybody, or every day of the year, everyone has access to you. You need that one day to yourself. So it doesn't necessarily have to be your birthday, but definitely should be one day out of the year where this won't be too much of a long stream. But you should have that one day out of the year where you focus on yourself and you focus on your peace and you focus on, just talking to yourself and isolating yourself away from other people. It's no offense to other people, but it's just you need a day to yourself. You need a day to semi-recharge. And sometimes you could do that over the holiday, especially if you're a loner of some sort, introvert, a person that doesn't have a lot of family or anything like that. That's definitely a time that you can actually do stuff like that. So I took that time yesterday. And the people that knew me hit me up and got the voicemail where I just said, "Hey, listen, you wishing me a happy birthday. I wish you peace and all together. And my other friends texted me and everything else like that. So that was really cool. I appreciate them. Love those guys. Um, what's it called? So with that being said, let's get into it. So we're going to talk about prototyping. So I've built prototypes, and I should have brought my other one out here. But for the Growbox project, the environmental case, actually, we could do a screen share. We can do a screen share. How do you want to do a screen share? So I'm going to go over to the growboxproject.com, share screen, share tab. Oh, there we go. Share tab audio. Don't think there should be audio, but share. Okay, so all right, so this is the Growbox Project website. This is my environmental control unit. This is a part of the project. This is codenamed STEM. And with this part of the project, it's just a nice junction box or a nice junction box, if you will, or circuit box where I fit a lot of like different pieces, technology, power, and custom connectors all in one small form factor. At the core of this is a Raspberry Pi. So you'll see that here on this picture. So I have the Raspberry Pi. This is powered by what I call the Tower of Power here. This is probably about, I think, two or three bus bars stacked on top of one another. And then I have those going to a set of relays. And then I have power that's supplied into it. And then, of course, the negative and the positive poles for the power. And then the relay I can control from the Raspberry Pi through these pinouts here on the relay board. And then I can, turn them on and off. And then I have this bus bar here, which is live. And that controls the fan and a couple other things in here, such as this thing here. This is a regular power plug. And what I can do with this is I can actually control this this DC power outlet here, and that went to a ball valve. And in that ball valve, I was able to, let me get the chat up here if there's anybody here. Don't want to miss anyone. With that ball valve, I was able to control, able to control the flow of water. So turning it on and off and making sure that turning it on and off, and then being able to control it in terms of the water flow and things like that. Obviously, I'm just like lost for words. So with that though, I could have, turned it on for refilling of the smart tank here, which never finished this here, but I still have this portion prototype here. And with prototyping, it's not supposed to be perfect the first time around. Like you're going to make a lot of mistakes and have quite a few revisions. Like right now with this current project, I'm already thinking about revision 2 going on to 3, and what I'm going to take out and what I'm going to put in. There are various notes that I have and that I what's it called, that I go over every so often. So even with this has 3 sensors. So okay, how can I get it to where I can put better holes in this bucket, seal it off, make sure there's no water loss, but I want to actually monitor everything in this bucket here. So how do I do that? How do I make sure? Oh, okay. Hey, Richard Dixon, what's up, man? Website looking sweet. Yeah, appreciate it, man. That's a fairly old website, man. I've had that for a while now, and that project's pretty much dead right now. I just haven't done anything with it. I'm moving on to this lawnmower thing. I jump around to projects, so even the fat project, I'll go back to it. But I started looking at this, and I wanted to. The money's starting to come in to where I wanted to get this going here. All right, so. And I'll probably start working on fat again next week. But with this, I'm able to do quite a bit. And you can see Growbox, and then this is from 2019, this actual board. And this is the second version of this board. There's a lot of holes and markings in the other board where I had all the measurements. This board was the quote-unquote finished product, if you will. And with this, I was able to, or with that, I was able to have a better understanding of, or better layout of everything. So this is a lot cleaner than what it was before its first iteration. Also, things like this pie, this little cobbler block, I think is what they call it, the pie cobbler block. I don't need that. I mean, there's no point, or the breadboard, that's what it is. There's no point in a little breadboard like that. I can just actually, once through my testing, I found out that I could have more than one temperature sensor on this temperature sensor unit here, because of the way the temperature sensors output the information or output their ID, because each temperature sensor actually has a hard-coded ID for the sensor itself. So even if I hooked up multiple sensors to one block, I can actually parse the data that comes in, or it's another device in the, I forgot what directory it is on Linux. But, I still have things like this, and I'll show you what I'm starting to use now with DIN rails and stuff like that in a second. All right, yeah, so website looking sweet. Yeah, appreciate it, man. But yeah, so I'll do things like that. But then how do I actually make something like that? Let's go ahead and I'm going to stop sharing. All right. So first off, I start with paper. This is just little cutouts, reusing paper. You can't, like, you see the back of it mostly because this is one of the things that I had in the, mapping out, in a sense, my circuitry, if you will. But this is for the 120 millimeter fans. So I would put this up to any case or anything else like that. As you can see right above me, this case here, I would put it up to a case like that, and I'd have the holes ready to drill. Now, this is just a paper template. I would put this maybe on wood later on, just so I can have something that's sturdy and longer lasting, or even something like plexiglass, which would be a little bit better, right? Because the plexiglass is going to be lighter, even more durable, because it's like a synthetic plastic material. Thinner, and then of course see-through. So, and then I could do things like hang it on there without ripping this up or anything like that. So something like this, what I did is I just came from Staples and I bought a folder here. So bought a folder here, and what's it called, bought a folder, and then I have quite a few inserts and paper inserts, so that I can actually store these things for the long term. So I'm gonna start doing that more. I haven't done it before, but I'm gonna start doing it now. And then of course using a hole punch. So if I have holes that I got to drill or something like that, I'll mark the center and then I'll hole punch it out. And then that gives me a better look of how everything's going. Also, with these paper templates, what's great about using paper templates is so you move up as you go along. All right, Richard Dixon says, I forgot about you have a workshop. You really a jack of all trades. I want to do some stuff with my 3D printer, but I am consumed by this programming for right now. Yeah, man, it gets like that. You know, like what we were doing fat for so many weeks, and I was, you know, taking my sweet time with that project. But yeah, you know, the jack of all trades things is great, but you know, also being a master of none, man, that's the other side of it. That is the dark side of it, if you will. But it's good to actually be able to have these different skills, you know, be able to not only cut wood, but use measuring tools like the L here, miter saws, grinding wheels, you know, like having all these tools at your at your fingertips is great. And then also having knowledge of these things, you know, could help into the future. So it's okay. So that's definitely that's definitely true, and it's definitely something that I like incorporating all of these different things, you know, technology with lawnmowers and so on and so forth. And it's a big undertaking too, because I'm doing it myself, but there's a lot of projects out there that are already doing it commercially, and I want to make this into a commercial product eventually as well. So I'll be building a bigger workshop. This is just my pump house, but I call it my workshop now because I mean it is. But I want a bigger workshop so that I can actually have a lawnmower in there, maybe even have it on the bench or something like that, and go from there. Yeah, so I first start off with paper prototypes. So paper prototypes, in this case, this is a little bit harder to read. I have some stuff in the background, so but you know, I'll say inside battery case. So this is inside the battery case. So that's this here, and I would put this paper template down in there, and this will be where my screw holes will have to go, right? Right. So this is where all my screw holes have to go. So I can actually drill through this, right? I can mark through this and then drill through the markings. If I had something like plexiglass or a wood template, and then I had the same bit or something like that I'm using, which is I usually use 5/16 bolts. I have no real reason for that other than that's what I picked up in the store, and I just keep using those bolts. And then those bolts and nuts. So I'll use that, and then I'll use a 5/16 bit and drill through something like this. Wiggle it around a little bit so I can have some space to move around, and then go ahead and drill everything from there. But now with something like this and having this template, I just put everything in the right spot, making sure that it's up to the edges. As you can see that with this, it fills that bottom. There's not too much play in it, and not having that play. Or that's what you can do with a paper template by not having all that play. So you'll have your measurements, and then you can you cut twice, if anything. So you have a little bit more, and then you cut off the little bits to a point where it fits in there perfectly, And then once I have my paper template, then I'll transfer that to something a little bit sturdier, like cardboard, wood, and then plexiglass. And yes, in that order. I use quite a bit of duct tape, a little bit stronger, and to put all this together as well. As I said, I'm starting to use the hole punch more. So something like this. The hole punch can't get all the way to this point here. So I'll just bend the paper a little bit and punch my hole. And I just try to maintain that I'm putting it in the center there. And that way I have a nice clean hole that I can actually mark through when doing all my prototyping. And this paper being bent, not a big deal, because you want to take this paper prototype, save it, of course, and then transfer it over to a stronger medium, cardboard, wood, and plexiglass. Plexiglass is more expensive, though. So wood, cardboard are good. Cardboard is not that great in the long run because it gets wet, of course, and it's the same thing as paper. Paper is nicer because it's lighter and flimsier, and you can mold it and say for instance, this is like this part of the page here. You could put it in there, crease it to the edge or into the inner corner of something, and then fold it, and then it has straight lines, so you can actually get straight lines from the paper itself, and then start going from there using levels, using L's to your measure, your angle, angles, L's, whatever you want to use to measure and make things straight. And having like, things like a nice level, of course, like that. This one is magnetic, so that's nice to actually have as well, in some cases. So having something like that, or having all of this, or using paper to do all of this, puts you in a better position in the long run, or actually in the beginning, so that you can actually make a better prototype in the long run. All right, so this is still not enough. I gotta bend the paper more. That's the only thing I hate, or that's the only thing that sucks about this hole punch. It is not long enough, or it doesn't go out long enough. So yeah, so you have your paper prototypes, and I'll paper prototype like everything. So I have this Inkbird ITC 1000F. So as you can see, I put the model number and everything on there, and then this is the cut template so that I can actually cut a hole in the top of. I can cut a hole in this thing here, so I can make that, right? And this is pretty tight, like this is, I had to bore this out a little bit more. So I might make another template like, as cut, or like as cut or something like that. And then template this piece here, because this template was just too small, right? So you can see how it fits in there, and then there's still space, right? So it's like, okay, this wasn't a good template, or it's a good start to get it, measured out, but then I had to work it out a little bit more, using a Dremel or something like that. And you want it to be where you can actually, you put these, you do these templates, and then you just cut it out, and then it works first time, no problem. Because then it's not like you don't have to do a lot of measuring or extra measuring or anything else like that. Close that before all those things fall out. I don't want to clean that up. Also design, like before, I was looking at a box, or the toolbox, which I'm using now. I was gonna make my own my own wood box, and thinking about everything that would go with that. And then I went to the store and found the toolbox, and I was like, okay, that doesn't make any sense to do that. Also, doing like layouts of your design, like what's going where and what I need to put in the box. So I did this while I was sitting at a restaurant, and I was trying to figure out like, okay, am I going to use only DC power? Am I going to use an inverter? If I have an inverter, now I have more space that's going to be taken up by that inverter. I might have to get a smaller inverter, things like that. So and I go through all of those things and all the little pieces that I need. Having a USB charger, and my main power source being a PoE switch for everything. So sorry, my main power source being a PoE switch for everything. So that will be the core of everything for power, and then everything else feeds off of that. Because then I can control things. I can even do things like shutting down ports and bouncing things if I needed to through that PoE switch. So I can restart the actual devices. Actually, no, I can't do it on this PoE switch. This is an unmanaged PoE switch, so I can't do that. Usually, if it's a managed PoE switch, I can do something like that, but those are more expensive. And then that fits my form factor using DIN rails, or DIN rails, Inkle rails. So this is the layout of the battery section. Let me see if I got it. This is the layout of the battery section. So right here, you can see one battery, second battery, and then the space in between. That gives me better measurements and placement. This right here is two pieces of papers put together, of course, as you can see with the duct tape. And with this, I can actually see, okay, I have to move it over here. I have to move this there. I can put something in the middle. How much wiring and space do I have? Or how much space do I have for wiring or anything else for my prototype toolbox? So it's like, okay, I can do all that with something like this. And then I have my fairly precise inch measurements. I'll probably start using centimeters, but I start getting into inches, and then I just forget about centimeters. So it's like a lot of small papers too. So that's why I wanted to get. I got the what do they call these inserts? Secure document pockets. So I got those. This is the main part of the toolbox as it is now. I mean, it's written in from all different angles. So with this, I can see through the hole here. So with this, I can, this is all the placement for everything. This is the initial placement, and things change over time. This is mainly just so I can actually cut out the board and, you know, put the holes for the mounting board, the mounting stud that's underneath it. Right. So I can drill the holes in the same place, and I should be fairly accurate. If I use something like plexiglass, I can be even more accurate because I can see through it. But yeah, that's it for you know, the paper prototyping. All right. So once I have everything in paper and I can start laying stuff out, now I start getting into the physical stuff where it's like I'm starting to put a lot of this stuff together. So I'll show you the box as it is now. All right. So this is a toolbox, an unassuming toolbox where nothing is awry except for that big ass vent there, right there, which is pretty cool. So I got a 4-inch vent on that. I've cut a whole bunch of holes in this thing. I've done quite a bit to it. As you can see, there's the power cables going to the solar panel. That comes out the back of this actual this toolbox. So stay on the outside here. I have my wheel locking test here, and you know, I got it looking better even on the other side. But you know, just testing out how like a wheel locking type mechanism. Hold on. Here I have a marine kill switch, so I can turn and isolate the power. So I could turn off solar power to it, to the battery and to the actual solar charger. So that will kill any power going to the actual battery itself, and then going to the solar charger. I'm saying that, and I think I might be wrong in the way I have everything wired. But essentially, this will kill the solar charger, so nothing. Oh, this does cut power from the. Let me get back to you on that, because I could probably do that better. And I noticed something last night where I cut this thing off, and I needed another isolation point so I can cut stuff off. But yeah, I can turn this stuff. I can turn this on and off with this switch, and that switch was probably about $15. I actually really like it, and it takes a really large gauge wire too, like a really large gauge terminal, like a 4-gauge wire terminal. But this is for marine applications, so it's outdoor rated, so it's waterproof, or water resistant, depending on how you mount it. There's a fan on the other side of this thing. I don't want to cut anything into the top of this, because when you're moving this up and down, you're going to have to worry about cable lengths. And then also when you're worry about water falling on this, I want to try and make this close to fairly water resistant, or at least durable, or able to handle, you know, sideways rains and stuff like that, which is why I have this 4-inch vent here for the intake. And I got a pretty high powered, or 1700 RPM fan. I'm probably gonna get some 3000 RPM fans, but I'm not sure, because I have to worry about efficiency. But I can get pretty advanced efficiency if I use smarter fans, such as PWM fans, pulse width modulation fans, or fans that use PWM technology. That way, I can actually control the speed of the fan as I need it. So I can have it go really, really fast for a long period of time, and then slowly cool down and maintain a constant power usage or consumption, and then also kick it up if I need to. So then it's be a little bit more efficient. So it's pretty much on-demand cooling at that point. All right, so let's open this sucker up. Oh, sorry, it's like hard. There we go. So this is the inside of the box. I did an Obfuscate.min video, so sorry for, you know, the shaky cam, but you know, I'm like really bad with this shit. So I did an Obfuscate.min video on this. I have a couple things going on here. I have some DIN rails mounted. I have a smaller MPPT based solar charge controller. I have some Dinkel terminal blocks in there, so I can hook actual DC power up to it. So that's a power distribution point. As you can see, the exhaust fan there. These pieces I can take out as I need to. I can also disconnect and isolate these Dinkel terminals by pulling these things out here. So, or actually, no, this was the disconnect point. I will have it go to another disconnect point. Let's see if I can get you a better. I actually terminated this here. So it has this square terminal connector. So it's a lot cleaner. And then I can put this into an actual DIN mounted DC circuit breaker. So I will be ordering that. I couldn't find it at my local Lowe's. Um, Here I have it a little bit janky with the battery. So I killed this battery, and I did not know with lead acid batteries, you're not supposed to discharge them past 50%. My dumbass killed this thing, and I wanted to kill it because I wanted to see how long it would last. It lasted for 5 hours after sundown, and I read or I listened, and it was weird because I put my my whole solar panel array back together and everything, and it wouldn't charge. Like it was just showing it's dead, and I was like, whoa. And then I watched the video, and then this guy was like, yeah, you're not supposed to sealed lead acid batteries are not supposed to be discharged past 50%. So I fucked this battery. At least I thought I did. Actually, I probably did mess it up because you can actually mess up the internals of the battery. Oh, man. Hold on. Let me talk to my dad here. Hey, Papu. Hey, let me give you a call back. I'm doing this live stream. Is everything okay? What do you mean you forgot my birthday? We talked about this. We talked about this earlier. Yeah, I said thanks for having me. See, that's what happens when you get a new truck, man. See, look, man. Listen, I can't talk to you no more, man. Yeah, oh God. All right, man. Well, we know your mating season is February anyway, so that's why we're all born in or that's why. Yeah, well, don't forget Fabian's tomorrow. He's closer, so he can actually key the truck if anything. All right, let me get back to this. All right, bye. Love you too. That's funny. My dad said he forgot that it was my birthday yesterday, and my dad is really good with birthdays. Like he remembers everybody's birthday, and what's it called? I guess he didn't call me yesterday, but it was okay because I was calling him to apologize that I had my phone on do not disturb, so I didn't hear anything from anybody because I didn't want to, you know. So I guess he didn't catch my clue earlier when I said, "Hey, thanks for having me," because my birthday's on the 20th and my brother's birthday is on the 22nd. So and that's the whole mating season joke because that dude, I guess he only fucked in February or something like that. At least for me, my sister, she was the first one. So, anyways, back to it, man. And fathers, very important, man. So with this battery, I have this in a battery tray. Now later on, I might not have this in an all-in-one toolbox setup like this. Most likely, what I'll have it is in something a little bit more aesthetically pleasing, such as that. And I'll show you how that looks actually on the lawnmower. That's a 200. Can I get this straight? That's a $200 junction box. Has DIN rails in it and space to add more DIN rails if I needed to. And I could do it's fiberglass. Actually has a door, metal plate in it. Really good construction. And I could put some holes and some other stuff in there as well. It is waterproof at the moment, but I got to put holes in it so we can put glands and other things in there so we can actually make sure that it stays fairly waterproof / resistant. But something like this is good because then this is also more portable. I can fabricate and put a couple other things in here. As you can see, the MPPT controller is connected and it's actually showing the battery in a yellow like light. On this controller though, I didn't get the calm. I'm trying to watch the stream itself, guys, when I'm holding this camera so I can see what you see. So excuse me if I look away every so often. This does have a temperature sensor on it and does have a control port, but it's not the same as my other, solar charge controller. So I have to get the proper monitoring tool for it so I can actually look at it and measure, how good the battery's charged because this doesn't have a meter or anything else like that. With that being said, so with this, as you can see, so from this MPPT or from this solar charger, it goes out to that switch that I have here. Okay, you can't see that, but it goes out through this hole here, and I got that switch mounted on the side. Not the safest, not water resistant or anything else like that, so that's a problem. Um, but essentially, what I want to do is this is a bit of a proof of concept, the MVC, minimal viable, or MVP, a minimal viable product. This is going to be something that I can actually test with further, and I can make some changes as needed. So there's going to be some more stuff that I got to put in this, and we'll go over that here right now. But this is how it looks. This is the foundation of it, getting all the electrical and power stuff out of the way, finding ways to isolate my power where needed. So cut off the solar panel, so cut off the power input, also cut off the power consumption uh, portion of it too. So anything coming in from the solar to the battery, cut that off. Anything going from the battery to the rest of equipment, cut that off. So having those different points, those choke points, if you will, or those cutoff points, is going to add to safety and allow me to do a couple other things in this box. So now with these DIN rails, actually I can kind of take that out. It's snug in there. Like, hold on. All right. Back to my face. Oh, man. Sorry for those horrible camera angles, the shakiness of everything. Well, I am Grizzly, so it is what it is. All right. So, got that board. I can pull it out as needed here. Yeah, I can pull it out as needed here, and I can place DIN mount or DIN mountable devices here. On the back, I put the screws through, and then I have an actual grinding/cutting or a grinder, and then I put the cutting wheel on the grinder so I can cut through these here and smooth them out. These are things that you want to you want to have these tools in place if you're starting to do prototyping of any sort. If you can get into access to somebody's shop where they have a lot of this stuff, it's great. You see a lot of YouTube videos where these people have like all these tools behind them and they're all perfect and everything else like that. Well, I wouldn't doubt they use them as well, but those tools are very important. And having different sizes of pliers and ratchet sets and hex sets and all types of other stuff and adapters. Like, one thing that is a freaking godsend is this thing here. So actually having this adapter for a ratchet, then I can actually have this right here is the 1/4 bit. So this is for the smaller ones. And then I have even larger than that. So I can actually take these off and use my drill to do that. That's beautiful to have. All right, so let's go over a couple things that I just got in the mail today. This is all about prototyping. So now I have some of these things in hand. So this is for an Arduino Mega board. With the Arduino Mega board, just like you saw with the DIN-mounted Raspberry Pi breakout terminal, I got one for the Arduino. So this is pretty cool. I like this. I've never used the Arduino platform, so I'm going to be learning that this week. I do want to make time for FAT as well, the financial asset tracking, and get back on that. But I will be working with this as well. So a couple of days I'll be alternating between the two. And that usually helps me think about one or the other and things like that. But yeah, so Arduino, the Arduino Mega 2560. So this is the revision 3 of the Arduino Mega. I just got the board itself. This is the packaging for it. Has some more information on the back. All right, so so in this case, the AT Mega 2560 clock is 16 megahertz. I'm sure that matters. I don't know yet. I don't know about it enough to be like, oh, okay, that's great. Memory, 256K flash, 8K SRAM, and 4K EEPROM. Interface USB, SPI, I2C, and UART. So there's different like serial connectors or inputs there. I'll be using USB. I'll be using USB to power it, and then using external powers or external power coming from the battery or other sources to power the actuators. Pinout is 70 digital, 15 PWM. That's what I need. I need all those PWM ports so I can actually start moving actuators in different directions. Raspberry Pi, I think, has like one PWM port, and since Raspberry Pi has a different clock speed or an issue with clocking, it's not always real time or it's off, so it's not the best. Oh, I don't need it. Sorry, I had the chat up in my phone, but I don't really need it right now. All right. And then of course the dimensions. Now with the Arduino or this Arduino board, it has I think three ways you could power it. So you could power it through the power outlet here. You can actually power it through the pins here, and then you could power it through USB. So I'll be doing it through USB and using a library. I don't know which one yet. I don't know which one's the best one, but I'll find that on npmjs.com. And I'll be doing it through Node.js like I always do. This board here, you could see, and you could find all this online. This is like a $40 board, and I went overkill because I don't know what I'm going to need for this board. So you can focus. I don't know what I'm going to need for this board or this project, so I wanted to get something that is a bit overkill with it. And it's 30, like, I mean, the Duo, which is the one underneath this, I think, with less pinouts and everything, and it's like $5 less or something like that. It's like, yo, get the Mega. I'll probably always get the Mega just so I can have that option to move up and down. I don't think I'll ever get the Pro boards or the Raspberry, the Pi Zero boards. Like, I just don't think I'll get those, mainly because of what I do. I like to have a full-blown operating system. Later on, that might be the case where I have things where I don't have to actually tinker with it and resolve anything or anything like that. It just works how it works. And I usually also like the network connectivity of it so I can get into it and do whatever I need to. What's nice about this, it also has ways that you can, like, it has a physical reset button. It has resets via the pins, which I think are right here. No, right here on this side. So it has resets via the pins. You can see there's like multiple pinouts and everything else. No. Yeah, I can't help y'all. Sorry about that. But you can view all this online, and they have really good pictures and a crap ton of documentation all over the internet for this stuff. This stuff has been around for years, and I've never used it. So this will be a new venture for me in a sense. So let me put this away. Oh, actually, no. Let me finally mount this because I waited to mount it with you guys here. But I'll be mounting it to this board, and then we can see how it looks on the DIN rails. All right, so. See me. Yeah. I lost connection for there for a little bit. Since I'll be doing more streaming out here, I guess I should get a wireless access one or something. I've been wanting to get one anyway so I can reach the other side of the lake and to the patio and all that stuff. So, or get more connectivity out to possibly a gazebo later on. All right. So with this breakout board or this DIN mountable adapter board, if you will. It also has a light on it, which is nice. So I can actually, when I'm programming stuff and writing stuff, I can actually blink that using PWM. It has a reset button on it as well, and all the other things you want from an Arduino that's natively on the Arduino itself, but it has them in terms of screw terminals with great labeling. So it has all the labels and everything, and then a couple other things in terms of power input and stuff. I don't know too much about that. Yeah. All right, cool. So take these and let's try this one more time. I don't know if it was the camera that like just died on me like that. Okay. All right, so just put that on there. I mean, literally, it's like really nothing. There should be on this one. There's no screws. On the Raspberry Pi version of this board, there were screws, but this is just push it on and that's it. So just gotta be careful. I guess it's foolproof. Yeah, V5. Yeah, okay, cool. I mean, I guess it wouldn't fit, but I was just being extra cautious there. Sometimes it's better to do stuff with gloves so you don't like touch or clean your hands so it's not oily or anything like that. My hands are fairly dry, and I just wash with water, and it's been dry for a while. Open sources love, definitely. So this is how it looks all mounted. So this product I like here already. I've already liked them. This is from Electronic Salon as well. I got this via Amazon, but this is a good part. Now I won't push too much in the middle. But now I can take this and then since it's put this away. Oh, this is another cardboard template. So this is how I like got that inner piece for the Inkbird unit fan controller. And even so, when you're doing all this prototyping and you're going through all this stuff, you'll see that you spent money that you didn't need to spend. Like I do that all the time. So I have a whole bunch of extra parts and I don't return anything. But then I can always use them later on. But you'll get parts that you don't need or are too big. So now that I understand more about PWM and then using it through the Arduino, now I'm going to start doing fan control. Like I'm just going to write the code for the fan control, use PWM through the use PWM through the via the Arduino, and control my own fans and control the variable speeds of the fans. So these boards, you can measure them out, right? But until you get them and then you get them in your case and everything, unless you have a pretty good mock-up and you have everything physical, like it's hard to see how these things look, how they feel, how heavy they are, construction. Like this is really good construction. So these are relays and I can control these via the Raspberry Pi. What's really nice about this is that I have screw terminals here, which is freaking amazing. I love that. Um, Screw terminals here, screw terminals here. On the other board, it was just a whole bunch of screw terminals on this side. Yeah, screw terminals. No, were they even screw terminals? Yeah, I think they were screw terminals. Yeah, they were screw terminals. So this is a nice hefty board. But then if I do something like, okay, let's mount it to the DIN rail. So with the DIN rail or DIN rail mounting technology, I don't know what it is, but like it's like DIN and then you have dinkles or dinkle rails or dinkle terminals or something like that. But they all have, if you ever look up Dinkle. If you ever look it up or the tech or the patent, I guess, or whatever for it, it's like one company that owns this, so they license it out to people. So that's pretty cool. Like they have their money from now until forever. But when you're going into like larger electrical conduits, larger electrical boxes, junction boxes, conduits, or anything else like that stuff will be ran like or larger panel terminals or whatever the hell I said, but larger electrical panels, some of them will be complex and they have a lot different control units and things like that. They will be mounted on Dinkle rails. Plain and simple. Very small rails. You can buy, like, I bought a whole set of these here. These are the Dinkle terminal blocks, and they just pretty much snap on like so. Right? And then when it's on pretty tight here. And then you could buy some other adapters to close off the open side of these because it is exposed. So it is exposed. And this takes about like a 10 gauge wire or something like that. So 10 and below. And then you have larger Dinkel terminals and tiered Dinkel terminals. So you can have, these are, connect one wire here, connect one wire here. Then you can daisy chain them if you have jumpers. And this is not really seen. I guess I could take it out. But you have jumpers that go from one Dinkel terminal or terminal block to the next. And then you just push those down. So I actually had to use a hammer to push those down. It's a pretty tight fit. I'll show you that actually. And then to take it off, you have to like pull off one side. Ugh, like that. I use a screwdriver to do it. Just makes it a little bit easier for me. I'll show you guys how it looks. I have my fans connected, so I gotta take that out. They're connected in like the most jankiest of manners. But that's how prototyping is. It's not perfect. So this one, you can actually buy these where they actually have them already pre-done in terms of the jumpers. This is how you daisy chain the jumpers. So you have this one and you just kind of tier them, stack them, or you stagger them. So this one goes to this one, but then from that one, it goes to this one, you know, just like that. So you'll stagger them. And now this is my input from the battery. And then, you know, and it has its connectors. So this will go to an actual breaker, a circuit breaker, to where I can cut all this off. If I didn't daisy chain them, I could have like just a pass through or a coupler like effect here. But with this, you can see that I have the Dinkel cover here on this one side because it's exposed, and I don't want it to touch or anything like that. On these Dinkel terminal blocks, they are, I'm trying to get the lighting here, but I guess you kind of sort of should see it. Yeah, right here. They are just like blank here and covered. So that's cool. Some I think some were exposed. I'm not sure, but maybe it's just exposed on one side. But these are cheaper ones, and I think I got like 100 of them or something like that. But yeah, these are working out good. And then what's nice is I use like the Raspberry Pi jumper cables here, and I'll screw them down into here. There are screw holes at the top, so that's how you screw them down and then secure them. I mounted you know, these terminal connectors here, or these these terminal connectors here, you can actually get the proper tool for them, and then you can have nicer connectors like this, so you can plug into stuff, and you don't have to have the actual exposed wire that strips or anything else, you know, that you have to deal with. But then this is all mounted on the Dinkel rail. So with this, I can actually move these in tandem since all these jumpers are in place, and then I can move them up and down. So that's really nice. But yeah, so that's one way I'm using the Dinkel rails right now. Put this back nicely. Okay, so yeah, I'm looking at this right now, and with the Raspberry Pi and switches and stuff like that, like this is not enough. I do not have enough rail at all. I just don't. So with this, what you're gonna do is on this here, this side, this side with this handle here, you're gonna push that up, and that's how you release it. So you line up this side here first, so it goes onto the rail. Screwdriver off. You line up this side first, so it goes onto the rail. And once it's like snug and on there, so you have to fit it. So let me just focus. Okay, I got it. All right, cool. So it's gonna clip underneath the rail here on this side, or underneath on this side. Then essentially, once you have it to where it can't move, you know, it's not, for me, it's going this way. So if I can't move it this way, I should have it secure, and then I just, after that, I'll, you know, have it on something sturdy, of course, and then I could just lay it down and go from there. And it clicks in place. Now, what's really cool about this too is that it's pretty tight. Like I probably have to use my new equipment, use a hammer to move this thing down, as that's the only way I can move this thing down. So that's pretty cool. What I'll probably do, because of spacing and again prototyping and all that other stuff, I'll move this down with the hammer. It's a circuit board, so it shouldn't damage it much. Famous last words. Because I need a couple inches for, and what I'll probably do is also put another set of Dinkle rail at the bottom. So now this is secured to this thing, right? Like it's on there. What I'll probably do is put another little bit of Dinkle rail at the bottom there on both sides of these, or on both these strips here, and then just cut it off. So I'll have to I'm gonna have to start cutting Dinkle rails and figuring that out. I'll probably use my miter saw for that to get that done. So I'll probably do that another day though. But I'm gonna get this on here and go from there. So now it's like with my spacing, I'm looking at this and it's like, okay, well, I can't put this here. So now I have to have wires that come from, because my Raspberry Pi is going to be here. And then I have those other set of Dinkle rails on this unit that is parallel to this board, right? So they'll be like this. And then I'll have this mounted here somewhere, right? So let's actually do that. I got to keep note of where I mark my fan. So my fan comes out to this point here. So, and I don't know if I want it too close to that, but I also have to account for a breaker. Oh, shoot. Over there. I also have to account for a breaker being put in here somewhere. So I might move this whole entire row of or these Dinkle terminals over. I do have them, labeled as positive, negative, and I also have it labeled as positive, negative on the top of the bar. My fan marker is right about here, so I have some room to where I can move these over a little bit. And let's go ahead and do that now. Another thing, when you're in like your little workshop or whatever, man, like this is actually somewhat clean, or usable, but man, when you have the toolbox up here, when I was working on it over the weekend or yesterday, I got some really good stuff done, but it was packed. And I care about I care about I think about things like, okay, the fan is this close. I need some space to where I can put my hand in there, so I have room for that. Like, how is that going to look? Not without like electrocuting myself or cutting my finger in the fans. And the fans, I will have a grill on them on the inside as well, so I don't have that scare or option or possibility, or lessen that possibility. Okay, put this down. Cool. What's nice is like once these are daisy chained, they're pretty much all together. And it seems pretty durable when you put all this stuff together. Like I'll put all the connectors in place, because as you can see, they're a little bit, you can kind of see them a little bit above the black terminals, but sometimes, you put them in and I was watching this one guy's video about it. Ice Money. Hey, what's up, Armani? What's up, man? I'm going to get back to writing, though. Keep going. All right. Talk to you later, bro. All right. Love you, man. That's my nephew. And hello, new here. Subbed the channel about a week or two ago. Okay. Hey, Tony, what's up, man? That's cool. Put you on blast. Hey, man, I appreciate that. Oh, my God. I just noticed my knuckles looks like I've been dragging them, but it's okay. We in the workshop. Yeah, man, I appreciate you subbing, man, and I hope you're getting something out of this a little bit. You can go back in the video, of course, and what's it called, and get a little bit in terms of what we're doing, what the project's about, and stuff like that. But I appreciate you being here, man, I really do. Yeah, so with these Dinkle terminals here, these Dinkle terminal blocks, this is the breaker, and this is the improper installation of the breaker. So this will not conduct power through it, right? Essentially, this fuses up. What is taught by the guy that sells this stuff is that you can either use a screwdriver. For me, I just bang it with a hammer. It's not like really hard taps or anything like that. And then you're gonna have to wiggle it out. So something like this, it probably kind of would damage it, but something like this, I'd use pliers. So get most of the body so that I can actually safely pull it out and then reuse this. This right here, it doesn't. Does it say? It doesn't say how much. Like, it's not a fuse per se. These are just jumpers. So this has the possibility of melting, and it doesn't offer any real protection for your circuit itself. So keep that in mind when you're doing that. Don't yeah, these aren't fuses, and it doesn't tell me how much. This is like 50 of these things, but it doesn't tell me how much. What's it called? It doesn't tell me how much amperage it could take, or current, or voltage. Or I think it's going to be amperage. Is what you're going to focus on. Alrighty, so in designing and prototyping stuff, like again, the goal here is to make a automated lawnmower, right? But it's just like, how do you do that? Well, I start at the basics, or start at the bottom. Like, okay, well, how do I power the thing? How do I power the electronics to do all the work? And then once I figure that out, it's like, okay, well, what form factor do I have? What is it going to look like in terms of putting everything together? And then from there, it's like, okay, what are the parts I need to make those things happen? What do I have to do? What are the tolerances? What are the things that I have to worry about in terms of power? So I'm putting these blocks together. Can I put these blocks that close to one another? Yes, I actually can. So I'm probably going to do that. But then, you got to worry about heat. So if I have to worry about heat, well, that's fine, because my fan should be right about here. So the fan that I'm using on that side is a smaller one. It's an exhaust fan. I probably will be using a bigger fan later on, and this will probably move. But I should be getting good airflow across these Dinkel terminals here. And once the case is closed, I'll probably be getting really good airflow in the case itself. And also, I might have to change where the fans are so I can ensure proper airflow. So, for instance, your intake fan will be here, and then your output fan. No, your intake fan will be here, and then your output fan might be here. That way, you should have airflow coming in, and then it get an exhaust over here, but it flows through the case itself to actually get that done. So if you have your fans running at the same RPM, then I should get a good air exchange, I think is what it's called. I'm not an engineer when it comes to that type of stuff. But I've been around enough air engineers and understanding a little bit to get a couple of things from them. And usually you're going to stagger your airflow. You're not going to have just airflow to airflow here, even though in my prototype that is how it looks. And that's only because I have a pretty narrow channel where all of this stuff is going to be. So a lot of this stuff is going to be sandwiched right on top of one another, if you will. And this is kind of like the channel that the air is going to flow in. So I can get away with that, right? It's just narrow. But if I have a larger box or anything like that, now I have to worry about, okay, are my batteries getting air as well to, the heat that they're putting off. So that heat actually gets taken out of the case itself as well. All right. So now with this, let's go ahead and flip this down here. So I got a little space. I can't put any fingers or anything through that. So that's going to be a problem. If I needed to add anything, I'm going to have to move. Actually, no, with Dinkel terminals, if I wanted to add anything, it'll be a problem on this side, whereas on the power side or the positive side, I can add more. But I can also add more going this way as well. So it's not going to be a big deal. It's just like I only have one supply coming in. All the others, there's no supply whatsoever. All right. So yeah, we want to put this block here. And with the Dinkel terminals, with the way it works is I can actually mount it this way, or I can mount it this way. And depending on the Dinkel terminals, and sometimes you can actually have them a mount like this, where it has the adapter or the locking mechanism in a different oriented in a different fashion. So something like this. Got my fans here. This is my intake fan here on this side. I just know that, but it would be good to market. But I know that the fan's going to give me some flow here, so I'll have good airflow on this. That'll be nice. And then I got to think about, okay, my fan is right here. I have a larger fan on that side. I will be ordering another set of fans that are PWM controllable, because they have they're like a 4-pin fan, so you can actually send PWM signals or waveforms, square waveforms to them, so that you can actually control them a little bit better. I think that's how it's supposed to be done. But all right, cool. So going through my head is like, okay, well, placement, like, and it's not perfect. It's not going to be perfect, so I have to just get over it. So it's like, all right, this is good enough. Boom, and then just snap it on there. Because what I'm going to have is the actual breaker here. Smelling something weird in here. I don't know, probably the wood that I cut last night too, and then smelling this wood right here. But I was cutting wood in here, and I'm kind of smelling that again. All right, but nothing's like burning or anything, which is good, I guess. All right, so here, anyways, so this right here, what do we got here? Right here is good enough for now, and then I could have maybe 1-2 breakers here, because instead of having an actual an external switch, again, this is us thinking about this stuff, right? Instead of having me having an actual external switch that cuts off power to from the solar panel to the battery, maybe I should have the external switch cut off power to the equipment here. So that's another thing I got to worry about and think about. Yeah, so there's that. Once I get that, and then I can have a breaker here, and you want to have those breakpoints or circuit breakpoints, just so for better design, and allows you to isolate different portions of the entire circuit or project in this case. All right, but that's it. So that's it for this part. Like, I have this all set up, and I'll get this programmed at some point. This is somewhat modular, so I can take this in and out. This is the space I have on this piece of board here. Yeah, so that's all I got for this part here. So let me just put that back in the case. What's nice about this toolbox is that, of course, it has wheels on it, and then with it having wheels, now I can do things like I can move it around, I can put it in different areas or stuff like that. All right. Oh, my beautiful visage. Hey, man, if you don't love yourself, who the hell will? All right. Oh, sorry. All right. So I need... Yeah, that's what I need here. The brains of the operation, the Raspberry Pi on some DIN terminal, a DIN terminal breakout board as well. And, I think that's all I needed. Ooh. Standing up a lot this weekend, man. It was all good though, man. Like, it's like it all worked out really good. Like, felt good, like, completing stuff and going through stuff again. All right. So, no more on my face. Okay. All right, so we have the Arduino here. Per everything I have here, this is the top. What I will have going on here is I will have a network switch on here at some point. I can't have the Arduino on the same thing as the Raspberry Pi. And one thing I did do as well, yeah, this is my upper limit here. This gets right about to the case. And then in terms of mounting this, how it's mounted, I can have everything mounted like this as well, so that I can have access to all the different ports, power, and all that other stuff. This will be powered via PoE. The PoE switch will be a DC PoE switch. So everything should be powered through it. Now this board here is what I'll be taking inside the house and then actually getting it powered up, and then working with the Arduino and going from there. So just separating it from this whole project. But that's kind of the nice thing about the modularity. I was going to say modulability, but modularity of this whole design that I have, this prototype design that I have. Because with a prototype could be really just having a table and all of this stuff connected via various wires on that table. So that's just something that you can think about as well. Or that could be a prototype as well. And even in some cases, what I'm doing now is revision 2 of someone's prototype, or 3 or 4, because I'm putting it in an actual contained space and worrying about all the other things that come with it, such as ventilation and heat dispensation and all this other stuff that you got to worry about. And of course, powering the stuff where it can be autonomous. Like I can't have a long cable being pulled behind my my lawnmower as this thing's running across the lawn. It'll run over the cable at some point and kill the whole project, and then kill everything at that point, and possibly call the lawnmower just to keep on going, because it has essentially the brains of the lawnmower gone. So it's like, how do I deal with that? How do I deal with kill switches and other things to protect myself and anyone else that get in front of the lawnmower? So that's one thing I have to deal with. One thing I was also thinking about is, like, once I actually do get a lawnmower, and I'll show you this conduit, this junction box. But once I do get a lawnmower, I'm going to take the blades off, and it will just, it won't run the actual. I'll find a way to disconnect the blades and the mower and stuff. So that's another thing. Alrighty, so I'm going to do this. So I have to think about a part that's not here, which is going to be the network switch. One thing I did already do is with these DIN rails, I marked out where I was going to actually put them on the board. So, and then I measured the inch that the switch itself is going to take up, or the middle of it. And then the switch should take up about, it's going to be mounted in a way to where the long side is going to be this orientation here. And then it protruding out will go up to about here. So like 4 inches or something like that. So I have enough space in between my my boards, the other DIN where all the terminal blocks are, and this board. And then I should have enough space for this between this DIN section and then the next. And I may have to move these DIN rails as well. All right, so what else are I gonna do here? Now I gotta figure out, like, where do I really want this thing, right? Like, how much access do I want to it as well? Also thinking about cables, being put on this. Am I gonna mount anything else here? For the most part, no, I'm not. I don't think I'm gonna mount anything on this side here. And I might mount my switch closer to the bottom if I can get away with it. So I'll probably mount my switch closer to the bottom. That'll give me more clearance on this. I can actually move this up here. Oh, it moves easier than I thought, than I said before. So I can move this up here, and then I got a USB cable that's coming in, a USB-B cable, and those usually have a long head to them, and they don't come in right angle connectivity. So I have to move this down right about there. So then I can actually put the USB cable over. I'll probably have a short USB cable. So I have a couple inches that I have to keep free here. Let's mount that there. So yeah, I mean, this is going to be pretty much my mounting for my Arduino. It is what it is. So far, so good. I like this. So I like this in terms of mounting and how everything looks. I have also extra space. I have extra space here, so I can mount the PoE switch. The only thing I worry about is how is this going to look in the case. So let's go ahead and do that, or in the toolbox, I should say. see how this looks. Wow, that looks pretty decent. Now I'm noticing that I won't have much space there under the Raspberry Pi because of the MPPT or because of the solar charge controller. So maybe I want to move that over here. But I got to worry about airflow because I got those fins there and I got my fan here. And as I said, like, you know, the space between my fan and my relay block, I got that. I'm really liking how this looks though. Maybe what I want to do is move the DIN rails, move them over a bit. But now because I cut off the heads of the screws, I gotta put in new screws. This is how it works with prototyping, man. So you guys can see that there. I have a little bit of space at the bottom. I think I need about like 2 inches or something like that. So if I do put anything in there in terms of like that switch underneath the Raspberry Pi over there, it's gonna be like right there at the back of that, and it's gonna be probably buttoned up against it to where I have to move this up a little bit. Now I do, if you can see that board there, and then the little plastic notches on the side of it, these notches here. This is where the board slides into. I do have space above the board, so I can move this stuff up. So that's a plus, right? And then that'll give me clearance for the USB cable. If anything, the side with the Arduino has to be a little bit shorter. We haven't even talked about wiring. You know, I have to have jumper wires that go from the Raspberry Pi to the relay block on the left hand side. But I'm liking that. Like, you know, you see how all like this coming together and everything, and you know, now you got like a whole box of technology and power all together, you know, and then trying to get those things all to work. And of course doing the pieces of it as well, like, you know, working on the foundation, the foundational power aspect of it, and then the technology that rides on top of that power. Yeah, I like it. So I'll be working on that, moving that up and down. That's not a big problem right now because, oh shoot, sorry, touch screen. Oh, that's what happened. Yeah, so that's not a big problem right now until I get this thing in. Oh man, I'm so hungry. It's not a big problem right now until I get some other stuff in. But yeah, I can move that up. I could probably move the Raspberry Pi all the way to the top, and that should give me enough clearance. And then I got to worry about connecting all these, anything here to any one of these pins or anything else like that. I got to worry about that and how that's going to work. So I'll probably be having some fans hooked up to different power supplies so I can put all this together. But yeah, so I'm going to take this inside the house and I'll work on it from here and start figuring out, well, I got to cook and then I got to study for meetings tomorrow and stuff like that. And there's a couple other things I wanted to get done too, but we'll do it another time. All right, guys. Thanks as always. Just in time, I guess. My pump here. That's why I got to get like a proper workshop so I don't have that like sound in the background. But guys, thanks as always for joining. Those that are catching the playback, I appreciate you. Shout out again to Aquatechie for the name of the project, which is the Grizzly Autonomous Mowing Robot. Yeah, I think that's it. And I appreciate you. Oh, too soon, guys. Too soon. I did want to show you some pictures, so hold on. Let me let this pump. It's my well pump, so let that go. Excuse me. Cool. Perfect. All right, cool. Let's first I'll share my notes. I use Google Keep. All right, lost the internet for a second here. I just have really bad Wi-Fi out here. Actually, it's pretty good because it's going through a brick house. Cool. So I picked up where I left off. All right, so I was just gonna call it a day, but my internet came back for a second. Hopefully, I can get through this next part, and it'll be the last part. Let's go ahead and share a screen or a tab. I don't know where it left off, so I'll gloss over some of the stuff that I did talk about. All right, so thanks for Aquatechy for the name, Grizzly Automated Mowing Robot. Essentially, I'll go through my note. I'll make notes, little notes like this, and keep, and wire seat kill switch to RPI relay. So with the RPI relay, I can actually reconnect these. I can connect the kill switch circuit, and depending on how the kill switch is made, and then I can actually control that through the Raspberry Pi itself. So killing the engine and stuff like that, which is really nice. Need angled duct for fans, so I already got one of those. I might get a second one for the exhaust side as well, just so I can actually control, like, the air coming in and making sure that no rain can just easily get into there, even for the exhaust side. And that's pretty much it. Nothing too serious here. So I'm going to stop sharing this one, and I'm going to share some pictures in my Google Drive. Okay, that's up. All right, perfect. Okay, this last thing, I'll run through this real quick. So essentially, this is the conduit box that I ordered. There's a video on the channel about it. And this is the seat folded up and exposing some of the under the gas tank and the battery. But I can actually take this conduit box and put everything there. Now, that means like battery and other things probably won't be in here, but I can fit I can fit all my electronics in here, and actually probably even go even smaller, and then have the batteries mounted somewhere else as well. Then have this case right here mounted to this seat, not rail, but the seat panel, and that panel flips up pretty easy. So I should be able to still flip it up as well. And then all the controls that are on the side of it. I just realized, okay, all the controls are on the side of it. You probably can't see my mouse. Going a little bit further here. Going a little bit further here, you can see the seat is flipped up. I would have this box mounted to that panel. That kill switch right here, kill switch underneath the seat. Don't know if you can see my mouse, but there's a kill switch underneath the seat. There's that cable that's coming from the junction box. But that kill switch, I can actually, I could possibly control that through a relay. And then to the left of the left of the box, there's some of the other controls, the ignition and things like that. And then to the right side of the picture, you'll see the lever. So maybe I can possibly hook up an actuator so I can control the level of the what's it called? Come on, stop. I can control the deck. So let's go deep here. And then this is also another mounting position. And this is just to the front of it. So I can actually put stuff here and still take the chair off and put some other stuff there. But with a box like this, what I'd probably do is have this deck here and fill that with batteries. And possibly mounting a nice solar panel or something like that above all of this, almost like a canopy, and that'll help with heat just a little bit. All right, that's it. I don't want to go too deep into it because bad connection, and it's just bad quality for you guys to have to suffer through. I don't want you to do that. Guys, thank you very much for those that are listening, and for those that are catching the playback, thank you as well. I wish you guys all the best, and I hope you're taking those times, those days to isolate yourself and reflect on your life and the things that you're doing, and the progress that you've made, because you have made progress, and hopefully it's a positive progress. I don't really believe so much in positive affirmations because people use them so much, and it dulls their senses and then disconnects them from reality. But I do believe in positivity and actually having a positive outlook on your life and some of the things that you're doing. As always, try and execute. With that being said, if you're not taking what I say with a grain of salt and you're low on sodium, go ahead and do your research. Start looking around and find your own truth, if you will. All right. Peace, guys.